Welcome back, everybody, to the Additive Snack Podcast. I'm your host, Fabian Alefeld, and today we are diving into the role of mathematics in additive manufacturing. May sound a bit weird at first, but my guest today is Harshil Goel, the founder and CEO of Dyndrite. And once we get into this episode, all of this will make sense. He has a strong background in mathematics and mechanical engineering, and as he will tell us, didn't really set out to enter the world of additive manufacturing in the beginning, but today is trying to solve many additive manufacturing challenges with pure math. So to me, that sounds super exciting. And in this episode, we'll unpack Harshil's journey, explore what Dendrite actually does. I don't think everybody knows how it empowers engineers and really pushes the limits of additive manufacturing. And last but not least, we'll also talk about a super awesome roadshow that Dendrite is putting on, and we'll give you more details on how to join that show at the end of the episode. So therefore, without any further ado, Harshil, welcome to Additive Snack.
Thank you for having me. I've been kind of excited. I've been listening to this podcast for some time, so I appreciate the opportunity to come and talk to you.
Yeah, awesome to have you, man. Really pumped about today's conversation to learn more about yourself and about Dendrite. And maybe let's really start with yourself. I think you have a cool and interesting journey into entrepreneurship and into additive manufacturing. Can you tell us a bit about your background and how you stumbled into additive?
Yeah, so my background essentially starts in California. I went to Berkeley for my bachelor's, master's, PhD program. My scientific background is in mathematics, specifically in differential geometry topology, which is a fancy way of saying I like doing calculus on surfaces. And my mechanical engineering background is actually in fluid mechanics, computational fluid mechanics, and continuum mechanics, which is basically a fancy way of saying I like solving very difficult mathematics problems for engineering purposes. And so, how did I get involved in Dendrite? I didn't even really know what additive manufacturing was. I had never really used it. But a couple of Boeing folks came to me and told me, hey, Harshil, additive manufacturing's an exciting field. We think that there's a lot of opportunity here, but we think the software sucks. Can you do something about it? And I was, in my master's PhD program at Berkeley at the time. And over the course of a couple of weeks, I was able to show them some interesting concepts and interesting solutions. And that was the origination point of our company.
Cool. And what year was that?
So those folks came to me basically 2015, 2016. And once I'd made some of those solutions, I cold called a few friends in what I guess would be called the propulsion industry. That's kind of where actually our logo actually comes from. And because they found some interest in that, I ended up leaving my PhD program, ABD, to start the company.
Super interesting. And yeah, I think many people stumble into additive initially and then accelerate. So 2015, 16, that was also somewhat of an inflection point, I think, in additive, right? We've made our way out of prototyping, went into production. There were a lot of questions on the horizon. And then did you start Dendrite right away, or was there something in between?
There was about 2 years of me going back and forth, basically talking to potential customers, trying to understand if the problem was the same everywhere or if I was just paranoid, So there was a lot of just customer discovery. I think our incorporation documents officially state 2017.
Okay.
And at that point, I basically Craigslisted myself a office, an apartment, and Amazon myself a bed. and moved to basically Washington because that's where some of our initial customers and employees were. And so it was kind of a hurry up and wait, but I didn't officially start. And when I did, it was kind of all of a sudden.
Interesting. Cool journey. Um, and now we're here. Now we have Dendrite as a somewhat established brand in the industry. I think also a very recognizable brand. I'm not sure everybody knows exactly what Dendrite is and what Dendrite does. So can you really explain to me and the audience, the core concepts of Dendrites and
Mhm.
what type of problems you're trying to solve today?
Yeah. And we often get this question. And I think it's because Dendrite does something slightly different depending on how much maturity you have in your process, right? And that's why, to certainly different categories of people, different things kind of jump out, right? But to simplify it, what does Dendrite do? Well, first and foremost, we make software. That should be clear. We do not make machines. We do not make parameter sets. We do not make materials. We make software, and
Hmm.
ultimately, that software is meant to help customers go from initial machine usage all the way to production. And that is a statement that I think has been said quite a few times. But I think what sets us apart is at least a unique empathy for the exact steps it takes to go through that process. So, kind of level one of maturity for a customer is they get their first machine, right? And
Hmm.
they want to import geometry, orient it, nest it, label it, support it, slice it, send it to the machine, right? This is what people traditionally call build prep. And this is probably the least sexy thing that we do, but it is a requirement, right?
Okay.
Step two is once the customer has made their first part, the next thing that they really want to do is make a specific part on a specific machine in a specific material. And
Hmm.
it turns out that that's not an obvious process. And that's what we internally call materials and process development. And this comes down to really appreciating the fact that all of manufacturing is about telling a machine where to do what when, right? And Dendrite's unique contribution to this, at least in this area, is about coming up with clever ways to apply lots of different strategies to the part, right? It could be something as simple as, I'm going to use a CNC analogy here. You can rough it and apply a finishing pass. We can
Hmm.
effectively do that in additive manufacturing and thereby increasing the quality of the parts and increasing the productivity of the machine. Once the customer has made their part, the next phase is they want to make sure, of course, that they can make the part again and again, right?
Yeah,
In
of
that
course.
process, there's qualification, there's calibration, there's traceability. There's a whole host of things that the customer needs to do to ensure that reliability and traceability. It's
Hmm.
only once they have completed each of those three initial steps, then they're ready for production, right?
Sure.
So as you can appreciate, each of those steps, cares about completely different things to some extent, but they are all interrelated and they feed into each other, which is why I think, describing what Dendrite does can be a little bit difficult because depending on where you are in your maturity curve, your MRL, TRL, one of those pop out.
Okay. So from traditional data prep, is that including on the metal side support generation? Yeah.
Yeah, yeah, exactly.
Okay. Okay. To parameter and process development all the way through qualification.
Mhm.
Okay, that's interesting. So you only have tools for different parts of the additive journey, but also for different target groups and user groups, right? You have oftentimes data prep individuals are a different human than the process and materials engineer.
Mhm.
So I'm guessing that's also somewhat of a challenge that you have to go through to kind of cater to these different target groups.
Yeah, I think traditionally, right, they are different user groups. But
Hmm.
in my experience, the people who have been the most successful in additive to date are the ones who realize that these user groups need to talk to each other,
100%.
right?
Yes.
And it's when they don't talk to each other that all of these issues arise, things take time, or bad expectations are set.
Couldn't agree more. And if I'm not mistaken, you have also a bit of an example that you can show us on visually how Dendrite works. Can you pull it up just to kind of take us through through a process flow.
Yeah. Let me pull this up for you here. Okay, so here you have standard application. There's a toolbar at the top of this thing, and so we'll come through here and basically just do some basics. So here I'm going to first import an STL file. There's nothing fantastic about that. Of course, we can also read in the CAD data. But the part of this that gets kind of fun and exciting is this little Python button here. So most people don't know this, but I taught the MATLAB and Python class at Berkeley for mechanical engineers. And so our tool is actually set up to teach people how to program, whether they realize it or not. So I'm coming in here and I'm, of course, using the GUI, but I'm actually generating Python code in the background, right?
Okay, so for people that are just listening, so you have an open scene with a platform. You just imported an impeller or a
Later.
Blisk, and as you are using your GUI, also Python code shows up, which is kind of interesting.
Right, and so where this gets really interesting is because now I can do something like this. Fabian equals 10. And let's say I want to make the X spacing equal to your name. And then I can make the Y spacing equal to 2 times your name. You can see here that I've now set up a relationship. And you can see how different things are, like the spacing is off, right? Further, if I come in here and let's say I create this label here, right? I'm going to hit go. And I just labeled everything. If I come in here and I actually reset the application, this is where essentially the power comes in. I can look at what I was doing previously. And instead of making this, a pattern of 2 by 2, I'm going to make it a pattern of 5 by 5. And instead of the text being part 0, I'm going to call this Additive Snack. And then I'll hit go. And you can see on the screen here that 25 parts were created, all with that label, fully automated. Right?
That's
so
fast.
What could have taken, quite a few minutes again, took seconds. And you can imagine that if you start doing that with supports, with, toolpath generation, with all the kinds of actions and items that people traditionally want to do in this space, you can actually start to tally essentially the amount of time that could be saved purely by just automating what people traditionally call these build preparation tasks, right?
Yeah.
I'm doing one last one on autopilot where we're going to load in a step file and essentially automatically generate the labels, the supports, all based off of the CAD color metadata on the geometry. Any questions about that or comments?
Oh, wow. Okay, so now I see the support. Okay, so so your tool now identified the application and is applying a support strategy according to the geometry or according to predefined rule sets for this specific part.
So this specific example, it's identifying the color on the CAD data and applying specific rule sets in a library. So it found the green surface and put the serial number. It found the blue surface, trimmed it to 60 degrees and put these kind of tree supports. It found the yellow leading edge, trimmed it to 45 degrees and put those block or wall supports. It found a red surface and put the extrude support. And then it did the whole thing and sliced it.
Super cool. So it's a very unique approach to a challenge, especially I can imagine for for companies that somewhat manufacture different applications and need to very quickly have their data prepped and push it out to machines to ensure a high utilization. Can you tell us a few customer examples that use Dendrite? And you don't have to say the name, but the companies that are actively using Dendrite, and how in their daily operations is it helping them to streamline their processes?
Yeah. So certainly on the build preparation side, there are a number of automotive aero rocket companies who have used it to basically make their own rules and recipes, so they can basically automate away all of the tedious stuff, right? Like we've done some, in essentially non-public really case studies with some customers where, for example, they proved to themselves that they would save $20,000 a week just labeling things because the whole process was automated, right?
Yeah.
The other kind of interesting case study is we were working with a propulsion customer who was trying to print some parts in Inconel. They had some ideas about what they wanted to do. They believed it was basically impossible. And with our tool set and materials and process development workflow, they were able to actually print it in 1.5 weeks, right?
Okay.
And this is with zero prior experience. There's no AI here, there's no simulation, none of that. Some basically pure basic math. They were able to make some, I think, guesses and get the process to conform to what they wanted to do, right? And by the way, that customer didn't believe it was possible until they saw it with their own eyes, right? And
Yeah.
they explicitly essentially said, we went from a year ago from having all these ideas and thinking they're impossible to now working with you and getting irritated with you that we can't implement the ideas every 30 minutes because we're now adding more and more requests to you, right? That mindset kind of shifted. So that's an example of materials and process development. They're able to do, they can essentially do DOEs or materials and process development with a production mindset, right?
Mm-hmm. Mm-hmm.
The Another example is we're working with a customer solving some very fun optic allocation problems. You can imagine once you have more and more lasers, 4 is already exciting. Once you add 12, that becomes even more exciting, right?
Yeah.
Because there's so many options with that. And finally, I think this is the one that makes me honestly quite the happiest. We have customers going across each of those groups that you talked about, actually helping each other. So, for example, the materials and process development people are creating recipes and pushing them so that the build prep people can just use them automatically.
Okay.
You have R&D groups developing qualification builds, pushing them to that group so that the build prep for example, an ASTM compliant build is automatic. It generates the report for the qualification folks. I mean, truly, I think I'm the happiest when each of those groups are actually communicating with each other and working together, because every single one of those interactions, I think, accelerates that adoption process, right?
Mm-hmm.
Ultimately, why do we care about these things? It's because if additive manufacturing stays in that first group, that build prep group,
Mm-hmm.
I think all of us will probably need to give up soon
Yeah.
because the market
Yeah.
will only ever be so big. It's only once we can pull everyone to the right that all the exciting things start to happen. We can actually start to focus on machine quality, creative ideas, new interesting applications. If we stuck in this group over here on the left, wasting $20,000 a week putting labels on things.
Yeah. It's not scalable,
Mm.
nor does it make sense.
Yep.
Um, You know what? I'm really curious on how people can really get started with Dendrite, because I could imagine that there are what you just showed, which is more of a somewhat like a very simple interface. But I'm sure the further you go down towards the process and material development side, I'm guessing the more complex it gets. So that one example you talked about, where a propulsion customer was building an Inconel part and reduced the build time significantly. Can we double click on that? Like, what type of changes were done in order to increase the productivity of the system? so significantly. And what does that look like from a user perspective?
Yeah. So I would say for the last 2 to 3 years, Dendrite's very cool, but it's very hard to use.
Mm-hmm.
And
Okay.
so a lot of effort has gone on our part to make it as easy as possible to use, right? Straight from the GUI, right? So a customer is able to set up a very sophisticated parameter setter strategy purely from the GUI, no Python required, and able to actually set up these strategies. Now, there is a caveat here. If you want to set up maybe 4 strategies on one part, clicking in the GUI, relatively easy, straightforward. We've documented the whole process and operationalized it. If you want to put 1,000 parameters in one part, I mean, you could click it, but I think there is a better interface and approach. Do you see?
Yeah.
And so there's kind of this natural way to encourage people to go down one path, right? Specifically for that example that you brought up with the productivity of the machine. In short, you can essentially just apply a skin parameter and then a internal core or productivity parameter, right? So you might print the skins at 30 or 60 microns, but you might want to print the core at 90 to 120 microns. And depending on the bulk part geometry, that very basic thing could result in a 2x improvement in build time,
Sure.
right? We're not
Sure.
talking about anything sophisticated here. We're just saying go fast where you can go fast and go slow where you want to go slow. And I think customers can actually hit that within a week or two, right? There's nothing sophisticated there. That other customer that I was mentioning wanted to go much further, and so they started in the GUI and started creating their own low angle parameters, printing lower and lower and lower without the supports. I think they're down to 10 or 15 degrees, something like that.
Mm-hmm.
And at some point, they decided they wanted to make the strategy so sophisticated that they went out of the GUI into the Python, right? And it wasn't that we were saying go use Python, that's the best. It was sort of a
Okay.
natural maturity point where they realized, oh, I get the value now. I understand what this is doing for me. And this is what's allowing me to make very strategic decisions, right? In my
Mm-hmm.
experience, our customers go through this interesting journey over the course of, I don't know, 2 to 4 months, where they start in the way that they're traditionally used to interacting with software like this, like build prep software. And by the end of it, dare I say it, they actually become addicted to a new way of doing things. And when you actually take that away from them, they don't like that. They don't ever
Yeah.
actually want to go back. So, I mean, I think this is as much of a maturity shift at the macro scale as it is for the customer realizing what isn't and isn't possible and where they can participate in the process.
Mm-hmm. And I mean, I think there's an interesting hesitancy of mechanical engineers towards coding sometimes, right? I think
Oh
it's
yeah.
not often taught, and it seems daunting, and
Hmm.
it seems like a three year road in order to get there. Can you maybe demystify that a little bit? Like, what does it take to get from? Because obviously, the true power of your tool gets unlocked when you get into the Python space, and I agree. I could definitely see a natural progression there because you kind of hit your limits of productivity, and then to push it further, you have to go deeper into the software and therefore into coding. What does that progression look like for an engineer who is not a computer scientist, or a math major, and wants to kind of like dip their toe into that aspect of additive?
Yeah, good question, right? So, the interesting part about this is the target user demographic for our tool is someone who actually has no coding experience or a beginning idea of it, right? Maybe they take one class at one point, or they have a cousin who did it once, where they've
Yeah,
done
okay.
something, right? And so the tool
Little sister. Yeah. Yeah.
exactly right, and the tool is architected to essentially seduce you into it, not in a
Okay.
very kind of overt way. It's just kind of natural, right? So
Yeah,
what
because I see the code right next to my what I'm clicking on my buttons, right? So it's always present, it seems.
Yeah, so I mean, where did that concept of Dendrite turbo mode come from? So I speak a number of languages, and when I'm learning a new language, I always like to see kind of like an English Spanish textbook or an English German textbook, where on the right is the language I'm the most familiar with, and on the left is the language I'm trying to learn. And if you actually look at that panel, the right is actually the normal GUI. It's what you would expect. Yeah. It's only when you open that panel that you see the new language, that new perspective, right? And so the idea was to not say, okay, you need to learn all this documentation, you need to learn all this code. Just use the tool as you're used to using the tool. The buttons are where you expect them to be. I haven't moved the gear shift lever. There is, some hierarchy here. So there is a little bit of subtle differences, but they're all meant to, in my opinion, actually make you a better engineer by helping you codify your practices. And then whenever you run into a issue or you want to do something special that isn't obvious in the GUI, and by the way, it would be not obvious in any GUI, right? You can kind of think of it as you can open the book. You can open the hood of the car and see what's happening inside. And it would be my hope that all mechanical engineers like to open things and break them.
They do.
Right? That is a natural curiosity, right? Yeah. And that is, I guess, a part of the seduction process, right? They open it and they start fiddling with it a little bit. And eventually they start fiddling with it so much that it doesn't actually become scary anymore.
Yeah.
Right?
That's kind of cool that you've incorporated that learning strategy from your personal language learning activities into your software. That's super interesting. How many languages do you speak?
I think 5. So English, Hindi, I'm fluent in. I took 7 years of Spanish, and then I took conversational Japanese and Russian, specifically because you have to pass language exams for mathematics at Berkeley.
Interesting. I only speak 2 languages. I feel bad.
I'll also say languages are a kind of a thing in my family. My grandfather spoke, I think, 7, and his great-grandfather spoke 11. So I think there's kind of a knack, is what I would say.
Yeah, you got some catching up to do. Only 5. Come on, man. Okay, so it seems like it is a somewhat natural progression for folks to transition into coding. What about just switching over from different tools, right? I'm sure a lot of the listeners out there, if they are already in production or even in research, they use other tools. How do I incorporate Dendrite because it seems it's more than a data prep tool, right? It's almost also functions as a knowledge management tool to capture different parameters and processes. What's the best way to kind of like integrate that tool into my whole process chain, especially if I am already in production and I want to figure out how to maybe optimize some of those workflows?
Yeah, good question. So, I think the people who are the most successful are usually doing one of 3 things, right? Number 1, they're starting a new program, at which point trying some new software might be interesting for that new program, of course. Number 2, as you mentioned, they're in production and they need to figure out a way to improve their margin. And so the impetus to use this tool would be, hey, build time is directly proportional to my part cost. If there's an opportunity to half or 1/3 the build time, let's see if that's possible, because that will dramatically increase our margins. If there is a way, and if, for example, the majority of the build time is supports, or there's a huge material component to the supports, maybe there's an opportunity to use the software to reduce the amount of supports on the part and print that, right? Those are tangible financial goals that we can assign value to that have direct application to any production process, right? If you can save off seconds on every single layer and you have 10,000 layers, that's how the rest of production manufacturing works, right? That's what you care about. And so that is kind of the impetus to trying something new, right? I would say that if you're just doing the same thing again and again and you're happy with it and you don't want to earn more money, don't use Dendrite. And I say that in sort of a facetious way.
Yeah, Yeah, no, of course. Okay, it makes a lot of sense. So really, I mean, it is a careful consideration, right, to switch software,
Ah,
um,
yeah. And
right?
so now we're getting into qualification, right?
Yeah.
Well, qualification, in my opinion, is used as a weapon in this industry. People use the Q word as a curse and as an excuse to not do something, right? And
Yeah.
because it costs so much, it takes so much time, blah blah blah, right? And so there's two ways to view that. Number one is the juice worth the squeeze, right? So is the potential value worth the cost of the qualification, right?
Mm-hmm.
And there are some reasonable ways to estimate that. The second way is to completely change how qualification works, which is what we are doing, right? The current qualification methodology is costly and time consuming because it is very rigid, right?
Mm-hmm.
It is also effectively trying to capture perfection because you're trying to fix everything in the process, right? You know as well as I do that no matter how much you fix the process, there is a control law in the machine, right? Like it's not actually static, it's just oscillating at some set point, right? And
Mm-hmm.
the
Yeah.
current approach is the way it is because historically a lot of this knowledge has been black box, right? So you want to essentially statistically qualify something as opposed to mathematically proving that there is a processing window and auditing and proving that you are within that window, right? So to that end, of course, it is in our best interest to make it as easy as possible to qualify things so you can switch between softwares,
Yeah.
right?
For
There's a
sure.
natural, I mean, if anyone was wondering why we care about this so much, it's because we want to make it easy to switch. And number two, you know, I would think that the people who, if someone were to make a piece of software to help accelerate the qualification process, if there are 100 customers and they spend $3 million a year qualifying things, and we could reduce that from a total $300 million contribution to 30 million, how much would that software be worth? Right? I mean, I view this qualification hurdle as an opportunity, not as a bottleneck, if that makes any sense.
Yeah, for sure. I mean, it's a barrier for companies to not only switch but also sometimes to get into additive or switch conventional programs over to additive or from one additive technology to the other.
Mm-hmm.
Can you maybe deep dive into that a little bit? Like, what's the difference now in a qualification process, and how does that work for especially industries where there are a lot of restrictions around, like the medical device manufacturers, the aviation industry, right? Like, how can Dendrite help these companies to accelerate these qualification programs in detail?
Yeah, so I'll focus on aviation because that's
Mm-hmm.
one I'm most familiar with. I've read all the FAA documents, the AIA, NASA 6030. Like I've read all of that, right?
That's
And
fun.
um, it was a joyous set of few weeks trying to understand and internalize that. And I started really that journey at ICAM, that's hosted by ASTM every year. Uh,
Yeah,
I
yeah.
highly encourage anyone who wants to learn about this to actually go to ICAM, by the way. Um, and in that process, I discovered a couple things. Number one, I talked to a very smart individual named Dr. Mark Benedict, um, and I asked him a qualification, and he told me something very obvious. He said, "It is not the government's job to tell you how to qualify something. It is your job to convince us that what you did was reasonable,"
Hmm.
which is kind of an interesting concept because it means that a lot of the box that everyone is putting themselves in is a self-imposed prison, right? The second
Sure, yeah.
the second key thing I realized was, I heard Mark Shaw, who's at NIAR, speak. I heard Cindy Ashworth at the FAA speak. And, they were talking about all these three-letter acronyms, PCDs, process control documents, KPVs, key performance variables, IQ, OQ, PQ, and different stages of qualification and where you're doing what when. right? We have an America Makes project, by the way, with Siemens Energy, where we detail a bunch of this, and I'm happy to share it with anyone who's interested. And in
Cool.
all of this, I discovered, um, I guess, kind of a loophole to some degree, and that is in the existing frameworks and standards that people have proposed, people have a specific set of KPVs. Those
Okay.
KPVs, or key performance variables, are things like hatch distance, spacing, laser power, speed, things of that nature. Okay. Being a fluid dynamicist, I essentially just asked, why is there not a Reynolds number for additive manufacturing? For those of you who are not fluid dynamicists, a Reynolds number is a way to characterize a fluid flow. And based off of how high that number is, you'll know if the flow is laminar or turbulent, right? And so the mental analogy I would draw is, okay, are there a set of numbers like that in additive that tell you if the process is keyholing or balling or lack of fusion or proper density? It turns out that if you take all the current key performance variables and create your set of non-dimensional numbers, you can create a new set of KPVs. And the key here is, because those numbers are ratios of all these other numbers, you can keep pretty much the exact current qualification framework just based on a new set of numbers.
Mm,
Okay.
okay.
So that's kind of the cheat.
Yeah,
Right. So
yeah, okay.
I'm basically looking at a
You
contract.
translate first to
I'm just
your
I'm changing the space. I'm
yeah.
changing the vector space from one to another. And it turns out
Mhm.
that in this other space, um, there's a lot more flexibility. For example, right, it is well known that non-dimensionalized volumetric energy density is a key factor. It is not the be-all end-all factor, but it is a key factor. Now, how does that expand the space? Right now, you might be qualifying a part to be printed at 60 micron layer heights with a certain laser power.
Mhm.
If we're using volumetric energy density, it doesn't matter if you print it at 120 microns, so double the layer height, or 30 microns, half the layer height, if you just adjust the power accordingly. Because on a per volume basis, the density of the amount of energy the laser is delivering to the material is the same, right? That's the ratio I'm talking about. Um, that alone allows you to apply many, many parameters to a part and allows you to start printing parts much faster without even having to requalify. Now, this is a very simplified example. There's much more complexity here. You look at the
Yeah, yeah,
geometry,
there is, but
enthalpy.
I get the
You get the
yeah,
gist,
I get the idea. Yeah,
right?
yeah.
You're not
Okay,
you're not
interesting.
qualifying a layer height. You're now qualifying energy, and that gives you all the flexibility you need to do some very interesting things.
Okay, okay. Very interesting. Um,
By the way, it also
cool
works
to
with beams. There's a very cool paper out of University of Munich that just came out. They actually showed that you can actually go between a ring mode and a Gaussian mode, and it's actually not that different. You can actually predict it quite well, right? So it's actually kind of removing the mystery of this, if you will.
okay. Yeah, Munich. That's where I'm from. Obviously, a lot of interesting research happening there. So you
Mhm.
mentioned ring mode, so beam shaping. Really, how do new technologies, from your perspective, how have they evolved over the past few years? I think we've kind of like seen another spike in innovation in additive on the hardware side, but obviously you're a testament also to the software innovation, where I think we hadn't seen much software innovation additive over the past years. It really made a big impact on productivity and also quality and qualification, all those topics we just touched on. So from your perspective, how is the additive manufacturing industry maturing? You've been in it for 15 years now as well. What's your kind of like perspective on that?
So I think so. Number one is the people. I think the people themselves have been maturing over the last decade or so.
Hmm.
They are much more sophisticated. They're asking much more interesting questions. And so that is pushing some of this innovation. Number two is the machines themselves have become just much more robust, to be quite honest. Right? They were
Yeah.
already robust in some venters, but overall, I think you would argue that they've been becoming more robust over the last decade. And when you're stop dealing with as many machine quality issues, your attention starts to focus on some different things. Okay, those things, for example, include the machine productivity, right? And what are the two ways to increase machine productivity? Um, you can look at the software that's driving the machine, or you can look at the business end of the laser. You can add more lasers, or you can start using new types of optics to increase the productivity, right? But they're
Yeah.
morally trying to accomplish the same thing in different ways with different sets of pros and cons, right? The other trend that I think is sort of obvious to people is the machine size and volume has been effectively doubling every 5 to 10 years, right? So when I actually started this
Mhm.
company, I predicted that there would be about half meter sized machines, and then there would be meter sized machines right around now. And you can actually look at this going all the way back to the original EOS, SLM, and MTT machines. If you
Mhm.
chart this graphic over time, you can
Yeah.
actually see them doubling in size every set period. And so it was sort of obvious that this was going to happen. That machine doubling is important because it caused all of the existing infrastructure to break at a certain point, right? Because if you have that big of a machine, how much data do you have to process to tell the machine what to do, right? At some
Yeah.
point, those things that software innovation that stopped about 10, 20 years ago, it breaks, right? Which is where some of that opportunity comes from, right? Like I sit on the NVIDIA Developer Council for a reason, right? The other bit of it is people, as they're getting mature and as they're discovering what the machine can and cannot do, I think we're at this unique point in time where a lot of people have realized that if they could get effectively a 5 to 10x productivity improvement from the machine, it would unlock a huge swath of use cases, right? And so, using some basic back of the envelope math, if you can print 2 to 3 times faster by just using better software, and you can print 2 to 3 times faster by having more lasers or having a 2.5 size melt pool due to a N light laser, 2.5, 3 times 2.5 times 3, you're now in the ballpark of 5 to 10, right? So I think
Yeah.
we're at this very interesting inflection point that I think, I'm excited for the next 12 months. Did that answer your question?
100%. Yeah. And you're on
No,
the
no, no.
developer council, you said?
They have a developer council where they
Yeah.
ask people to help provide feedback about drivers,
Okay.
areas they want to take the GPU, the library.
So what role do GPUs or advanced chip and therefore also AI developments then therefore play to additive manufacturing from a control side, but also from a automation and productivity perspective?
So
That's an interesting point of view we haven't touched on.
yeah, so um, I don't know if I can comment too much about AI. I personally think it's a bunch of hype and nonsense. To be honest, and a lot of this AI stuff, there is some value there, but I think there are some much lower hanging fruits that need to be solved to make that AI actually useful, right? Um,
Okay.
but how are we actually benefiting from this AI craze? AI, in the traditional sense, which I think most people essentially refer to large language models, they're increasing the compute capacity of the GPUs in a very specific manner. Again, if you look at the GPUs, they're also effectively obeying their own form of Moore's law, where they are getting faster and faster and faster every year and costing less and less and less from a compute standpoint. We at Dendrite use that compute to analyze the geometry and make suggestions to people for where they should put different parameter sets.
Mm, okay.
Right? That's one example. There are many mathematics computational problems that can be GPU accelerated. And so to me, the Bitcoin craze, the video games, the VR, the AI, they might have some influence on additive in the future, But in actuality, to me, the biggest influence they've had is they've encouraged people to put more money in GPU development, making the chips faster, which enable all these computational geometry algorithms to be faster.
Gotcha. Okay, so a nice side effect, and it's getting cheaper too to run compute, right? Which makes it more accessible as well.
I mean, the average VRAM, I think for like an NVIDIA 1080 was somewhere like 4 to 8 gigs maybe, and now most of these chips are like 24 gigs plus, right?
Yeah.
Just in a small span, right? In terms of flops, we 5 to 10 years ago used to think about the flops, floating point operations per second. That's what that means. That was measured in gigaflops, so thousands of flops. And now they're being measured in teraflops and petaflops, right? So we're talking about 1,000-fold increase in compute speed, right? Those have effects. And as you can imagine, when you get larger and larger machines, you need to use that to develop the toolpath for those machines.
Super interesting. Yeah, I'm glad we took that little detour.
Yeah.
Thanks for that. I think there's so much more to learn about Dendrite and yourself, and we could probably spend a few more hours on this podcast. But what is cool that you guys host road shows all over the world. The next one is in Austin, actually in the facility that I'm standing in right now. Can you tell us a bit about what people can expect from that roadshow? Why should they show up? And a few more pieces of information on that event.
Yeah. So the intent of the roadshow is purely education. We appreciate you in Pflugerville hosting us at that EOS facility. The roadshow is free, so anyone is welcome to come, right?
Cool.
And the intent of the roadshow is education and showing what's possible with the machines. So it was my hope that, as like a side effect of this roadshow, to demystify supportless printing. I think that's kind of a fad topic, at least in additive. And so one example is by the end of every roadshow, every attendee who attended the roadshow has an idea of how to go print supportless 718 by the end of it. There's nothing fantastic about it. The idea is that it's completely demystified. Further, we encourage everyone to bring their laptops to the roadshow because everyone gets to play with the Dendrite software. We don't, by the way, install anything on your computer. We deploy a cloud instance version of the software, and then everyone can just access it via QR code on a website. So everyone can basically participate in a group learning session. And if you want me to tease it, I.
All right, now you're muted.
If you have time, I can show you one of the things that we normally teach people.
Yeah, do it. That'd be awesome.
All right. So I'm going to just run one of these sample examples. You will do this fully from the GUI in the roadshow. So it loads in this fingers build. It quickly puts serial numbers on all of these parts. You can see they're down to 20 degrees. This is a classic DOE build. And right now, it's already generating all the slices for that build. And we're done. By the way, I did this all on my laptop. We generated some very sophisticated downskins on this part. And there you go. We've operationalized how to print in 718 without any supports. So I know I ran through it very quickly on my computer. A part of that was to honestly show off how fast the tool is.
Yeah.
But in the roadshow, you'd be able to manually do it through the GUI and learn.
Okay. Well, then let's not demystify it anymore, so people actually show up.
Yep.
Super awesome tool. Thanks for educating myself and our listeners prior to your roadshow on this podcast. I think there's also some cool swag I saw as somewhere online. Some cool visuals.
Yeah. If you come, you can get a shirt with the band tour logo on it.
Yeah. Some dude with laser coming out of his eyes. Looked really
Absolutely.
Cool. Yeah. All right, man. Well, actually, it was super awesome to have you on the show. Really appreciate you spending the time. I know you're very busy traveling the world right now. So yeah, thanks again for being here. And I'm excited to also see you then in a few weeks in Austin.
Yeah, likewise. I appreciate this opportunity. To your listeners, thank you for listening to me if you've made it this far. And yeah, I hope you come to the roadshow and participate. network with fellow users, and enjoy and learn. So thank you again for this opportunity.
Awesome. Yeah. And as Harshil said, we'll also drop the link into the show notes for you to sign up. Share it with a friend or colleague if you want them to also join you on the Roadshow, or if you just think that this episode would be interesting to them. You can also leave us up to a 5-star review on your favorite podcast platform. This was the Additive Snack Podcast. I'm your host, Fabian Alefeld, and I will then see you next time.